Okay, moving on to example 6. Find a polynomial function, so p of x of degree 3. So let's first of all focus on the directions here. Polynomial functions p of x, or f of x if you want to call it that. And it says degree 3. What that means is my first term is something x to the third power. Okay. I don't know what the something is. I don't really care what the something is. But I do want you to get this done correctly. I do want the polynomial function to have all integer coefficients. I don't want to have fraction coefficients. That's not going to happen on this one. But if the zeros happen to be fractions, you're going to get some fraction coefficients. You're going to have to modify that. All right. And I don't know if it's going to happen or not. I'll just demonstrate if it should happen, how to handle that. All right. So what we need in order to do this is we need to know all the zeros. If we know all the zeros, we can do it. All right. And if it's a degree 3, we have to have at least 3 zeros. All right. So 1, 2, negative 3, 3 zeros. And all you have to do to make a polynomial function is this. P of x equals x minus the first one times x minus the second one times x minus the third one. Right? That's the polynomial function. The last thing to do, though, is to actually multiply it out. Okay, FOIL it, distributive property. So if I FOIL these two here, x squared minus 3x plus 2, I just shortcut FOILed it. First times first is x squared, last times last is plus 2. Negative 1 and negative 2, negative 3 is negative 3x. So it's always x squared if it's just x's, right? And then product sum, quadratic structure. That's being multiplied by x plus 3. The next step is to do the distributive property here. So I'm going to multiply x times everything here. That makes x cubed minus 3x squared plus 2x. And then I multiply 3 times all that. I get plus 3x squared minus 9x plus 6. And if I simplify it out, I get p of x equals x cubed minus 7x plus 6. The 3x and minus 3x squared, the 3x squared and minus 3x squared cancel out. Real simple to check these. Y equals the function that I just made, x cubed minus 7x plus 6. Go to our table, and the zeros should be 1, 2, and negative 3, right? 1, 2, negative 3, all 0. All right. Verifies that we did everything correctly, so all is well there. All right. Degree 3, polynomial function. Zeros are right. That's the right answer. Now, suppose you do all this work, and you end up with p of x equals 1/2 x squared plus 2/3 x minus 7. Let's say you get that. Okay. That polynomial function has whatever answers it has. I should probably make one that has good answers. Hold on. At least one good answer. Alright, that has a good answer. Okay, so I'm looking at that. What I noticed is that I got 1/2 x squared, 2/3 x minus 22. That's got fractions, and I don't want fractions in a polynomial function. So what I'm going to do is I'm going to multiply the entire thing by 6. Okay, I'm not going to change p of x. Seems like it's illegal, but all multiplying by 6 does is it changes the values of these numbers. It doesn't change the zeros of the function. So again, our direction is going to be to create a polynomial function that has these zeros. So it doesn't matter if we modify these numbers in the process, the zeros will be the same for both of them. So 6 times 1/2 is 3. 6 times 2/3 is 4. And 6 times 22 is 132. If I were to type in both of these functions, 1/2 x squared, 1/2 x squared plus 2/3 x plus minus 22, and I typed in 3x squared plus 4x minus 132. They don't make the same graph because they're different. if I was to graph, they're going to be different. All right. So let me go window. Hopefully that's big enough. Let's make y min and max. Let's go negative 100 to 100. There's our first one. Here's our second one. So what I want you to see is they're different, right? But at 0, they're the same. And again, that's what we're considering is make a polynomial function that has the correct zeros. So if you multiply every number by the same number, the zeros remain the same. And if we go over here to our table, I know 6 is one of the zeros. I don't know what the other 0 was. Like negative 5 thirds maybe. No, it was more like negative 16 thirds maybe. Nope, negative 16 thirds. Negative 14 thirds. Nope. Negative 17 thirds. Negative 19 thirds. Get closer, negative 20 thirds. Negative 22 thirds. There it is, negative 22 thirds. All right. So they both have the same zeros. They don't have the same everything else. All right, that's the thing to look at. So keep that in mind that if you're making a polynomial function, I want all the powers, all the coefficients integers. If you happen to get fractions, just multiply by the common denominator. Again, just leave p of x as is. The zeros will be right, even though the functions aren't exactly the same. I just want to have all integer answers on those. The only reason that would happen is if you had fraction answers, you're going to get fractions in your multiplications, and that'll deal with that.